I'd like to start by thanking everyone for being here. I'm Dave Bachman. I'm the Plumbing Mechanical Chief Inspector for City of Albuquerque. Today we're going to be doing some talk about the new IECC code and some of the requirements for commercial. So that's the mechanical plumbing update training. I'd ask that everyone remain on mute unless you have a question. You can also ask questions in the chat function of the Zoom app. This helps reduce some background noise. This is being recorded, so be advised. If you make comments or commentary, this will be captured and available on the city's website. That's where this will be posted once it's done, and we've kind of edited it a little and taken some of the bugs out. So can everyone see the slides, the housekeeping slide that's up there now? Of course, I can't see
Yes,
you,
Dave.
so okay, excellent. You all see it. So are there any questions about any of that, the being recorded, or questions or chat? All righty. So the IECC has two separate components. One's commercial, one's residential. This will be the commercial portion today. In the future, we will give another presentation like this for the residential portion. Excuse me. Mechanical systems typically on commercial projects are going to be designed by an engineer or some sort of design professional. The documents will require statements describing design criteria, equipment schedules, which should include types and efficiencies of the equipment and the controls. Commissioning plan will need to be submitted as well, if it is required, and we'll talk about that a little later when it is required. The more information you got up front and you provide with submittal, the faster and more efficient we shall be in the city approving your plans. So I got a couple different pictures of things. The one on the right is the commissioning compliance checklist. These are all the things that will be required for commissioning. You got to go through all these different components, get it signed off by the commissioning provider, the building's owner, or their representative, and this would need to be present at the time of finals for a CO. The energy plan review checklist is similar to what it used to be, but it's a little different. And Land may correct me, but I think this is the important stuff we need is the heating and cooling size, where this information has to be required, but the checklist doesn't have to be presented to the inspectors. I think that's what I remember. So I hear nothing, so I must be correct. So the vent system details are going to look a little different, or maybe not. You need to include fan horsepower, control system operation. So there's a snapshot I took. I'm sorry it's not super clear, but on the right side you can see, the horsepower is in watts, phase, voltage, cubic feet per minute. You're getting more information that specifies that it does in fact fall into the proper requirements of the IECC. So the equipment efficiencies, They've changed, they've gotten more efficient. So this is what you've been looking at in the past. This is the new 2018. The outputting of the heating and cooling equipment has to be not greater than the smallest available equipment that satisfies the need. So say you have the requirements are for 2 3/4 tons of cooling. Well, you would have to put a 3-ton unit in, not a 3.5 or a 4. So they want the smallest piece of equipment that does the job in there. Not I've got a 5-ton on the shelf, I'm going to put that in. So that will be something we will be looking at to ensure, probably in plan review as well as on the job during inspections. And if anybody has questions, I'm not sure I can see the chat, but Ms. Brown is reading the chat and will interrupt me and ask questions should that arise. So off-hour controls. Heating cooling zones independently controlled by some sort of a programmable control system. And those systems will be set back when the building's not in use and start the equipment before it's occupied so it's comfortable. So that's just another functionality. You know, at the end of the day, everyone goes home. It automatically rolls it back, cools the building a little so you're not heating it when it's not needed, and warms it up so when people get there, it's comfortable. Automatic controls serving guest rooms. The equipment in hotels or motels with more than 50 guest rooms, those are required to have controls that adjust the temperature not less than 4 degrees within 30 minutes of an occupant leaving the room from the occupant set point. So this is, they're talking about key cards to sense when you come and go, probably other sensors to address when the system should roll it back. So demand control ventilation. Simplified, the more people, the more outside air, as illustrated in the little picture in the upper right. The fewer people, the less you need. This is typically sensed with a carbon monoxide type of sensor that will automatically sense when it is required, when more is required, and less is required. And depending on the size of the room, if larger 500 square feet, occupancy load of 25 or greater per 1,000 square feet. The table on the right tells you what percentage or cubic feet per minute you're going to need. There's a lot of control stuff in the control requirements in the IECC. Just making it more efficient, less personally interactive, I would imagine. You know, it's all automized, so these things do happen. So probably not so much in commercial as residential, but the energy recovery ventilation systems. I think this has been happening already. So based on the time the system works in an average year, there's 2 different charts that would require different amounts of of fresh air to be transferred. So under 8,000 hours per year, which I did some math, that's every day except 31. So more than 8,000 hours a year, you know, you're operating all the time. So I would imagine a lot would be under the less than 8,000 hours a year. You know, the office buildings where people aren't in on the weekends, and how often the systems are operating. They may operate at all, you know, 24 hours a day with setbacks for certain times. But the more time it's there, the more requirements. Now I've highlighted in yellow our zone, we're 4B. So those are the charts we would use. So it's not required on less than 8,000 hours per year. More than 8,000 hours a year, you have different amounts for what your design airflow is and your CFM and flow rates. And I'm hoping you're all still there, because, you know, otherwise I'm having a good time by myself. So ducts and plenums, insulation and sealing, that changed. It went up just a little. It was R5 for unconditioned spaces. Now it's R6. Outside, it's R8. All ducts and pipes carrying conditioned water or air are required to be insulated to prevent heat loss or gain. So that it's a slight change, but it is a change. Piping insulation. Now we're talking about mechanical piping insulation, not domestic water type stuff. Heating and chilling and cooling piping that's transferring fluids to the system to heat or cool. So if it's below 60 degrees or above 105, it's required to be insulated. And the chart on the bottom tells you, depending on the temperature, what the thickness of your insulation should be. So it's sizable, depending on how hot it is. The hotter it is, the more you want to retain it, so the thicker the insulation. The insulation will need to be protected from sunlight, moisture, wind, general damage when you're working on it. You can see some of the insulation here is torn a little. It's, you know, kind of taped up. It's getting rotten. So it's going to need to be protected from all that, because if it disintegrates and goes bad or isn't there, it's not doing anything. So just throwing Armaflex up on the roof or on a sidewall isn't so much going to cut it. So heat traps for hot water storage tanks. Now, a lot of water tanks, hot water tanks, storage tanks, water heaters in essence, have these built into them. If they don't have an integral heat trap, one will have to be piped in, and the picture here illustrates how that works. Basically, it's to keep it from siphoning out and transferring across. So should you need to pipe one in, this is basically what it looks like. As a plumber, I haven't seen one in a long time. And then the first 8 feet of piping must be insulated. The inlet must be insulated through the elbow shown there. That's to keep more warm water where it's supposed to be. If the inlets and outlets, well, this is on the vertical inlets. So as illustrated, the outlets on top of the tank type water storage tank. Side outlets, you're going to have a different issue. You're not going to have this because the heat isn't rising like that. Tank inlets and outlets for solar water heating systems with circulation loops, they're not required for the heat traps. So solar's getting more popular. I don't know, it's probably more energy than heating water, but should that happen, that wouldn't meet this requirement. And again, the insulation of the piping, there's the chart again. And now we're talking about domestic. Gives you again, the thickness and the insulation factor for all the piping. The hotter the piping, the thicker the insulation, which I would imagine in the 105 to 140 category, which is where domestic hot water is. Now you've got to have inch to inch and a half insulation on pipe, which makes it a little more difficult to get into a 4-inch wall. So just keep that in mind.
Dave, we have a question.
Go ahead.
Okay, it's from Brad J. How is the heat trap insulation dealt with in the existing buildings that do have pipe heat traps? And the replacement water heater does not have the heat trap integral to the unit.
So in an existing building, let me see if I got the question right. In an existing building, you're replacing a water heater that has a heat loop. I apologize. Could you read that again?
Yes, sir. How is the heat trap insulation dealt with in existing buildings that do have piped heat traps? And the replacement water heater does not have the heat trap integral to the unit, an uninsulated heat loop.
So if the existing has an integral heat trap and you're putting in a water heater without one, storage type tank without one, you would have to pipe it in and then insulate the first 8 feet. If there's already a piped heat loop, and you're putting in a tank type water heater or storage tank that has an integral heat loop, I don't think it does any harm to have the extra piping in there. And it wouldn't need the insulation anymore. I mean, if it's already there, I wouldn't take it off. I'm not sure if that answers the question.
Dave, this is Lance.
Sorry. Oh.
Just as a general though approach to the energy code, if you're not changing anything, or the new code doesn't apply. So if you don't have to change the piping and you're just changing out the equipment, then you won't have to adjust the piping unless, of course, the equipment requires it. But that applies to everything in the energy code. It's truly this, you touch it, you buy it idea. You just leave it alone and it's obviously safe and code compliant, then the new requirements of the energy code would not necessarily kick in.
Thanks, Land. I think that's what I was getting at, is if we have an existing uninsulated condition and we're just replacing the tank, would we have to locate those lines and insulate them? So
no.
Thank you.
All right, sorry, misunderstood the question. And we will get into later in this presentation something about existing buildings, additions, repairs, that kind of thing, and where the energy code falls in and what it would require and what it wouldn't. So that will be coming later, but thank you. What happened? I'm frozen. There we go. So this is a little different for designers and installers. The maximum allowable pipe length method. It took me a minute to wrap my head around what this was getting at, but what they're going for is on a public lab, and I have a drawing on the next slide that'll kind of illustrate it a little. Historically, we ran a trunk line down a hallway and branched over to public labs, you know, run it over and down in the wall and you're good. This is to eliminate that excessive pipe length so you don't have to drain that whole half-inch line down before you start getting hot water. This will, in essence, as I will show you, you're gonna have to pipe over to it and back up and make a loop out of it. Now, if you have a gang bathroom, that's fine. You drop down on the wall, run past them, back up and out. It's a little easier. Now, that's on public labs. Other fixtures, you've got a much greater distance, and this chart demonstrates some of the lengths and distances. The larger the pipe, the shorter the distance, because you've got more volume you've got to remove the untempered water out of. And this goes up to the point of distribution, which is your angle stop in essence. So let me show you the next picture, kind of get what I'm getting at. So at the bottom, you've got some public labs where you see it loops down to each one and back up and down and up and down and stubs out. That eliminates the length of pipe, or, you know, gets it in those requirements. Now the break room sink on the right, you can just run down and out because it's not a public lavatory. So those requirements aren't the same, because they figure, you know, public labs get used, and we've all been there. Try to wash your hands with warm water. Doesn't happen. So this will get the warm water to you quicker and without wasting so much. Now, gang bathroom, 3 public labs on the top, just loop down and you know, go right by all of them and stub out at each one. Just different ways to design it. It's going to be a different way to pipe it. The next one's a private lab. Now, it's not a public. Say this is an office building and this is the CEO's private bathroom with a shower and a toilet and whatnot. That's not required because it's not public. Shower, same thing. You have more length, you can just run it down. So, so back to the chart, it shows you a 1/2-inch line, maximum amount of 1/2-inch pipe you can have off of the main, in essence, is 2 feet. Typically, we would run it down a wall 6-7 feet to stub out below the cabinet or below the lavatory. You can't do that anymore. So that's what that is. Any questions on that? Okay. Heated water circulating, temperature maintenance systems, circulation systems. Basically, you need a pump, circulation pump. The gravity thermosiphon circulation, can't do that anymore. I don't know the last time I saw one of those, but that may be, somebody may want to design one, but can't anymore. It's going to have controls that start the pump based on the identification of the demand for hot water. Controls turn the pump off when it reaches a desired temperature or where there's no further demand for the hot water. Heat trace, it's a way of keeping the piping hot. Again, it's going to kind of operate the same way, where it'll have a sensor in it, and when the water reaches a temperature, it turns it off. When it cools down, it turns it on. Doesn't so much circulate as it does just maintain the heat throughout the whole system. They have a 5-minute limit at the end of the cycle for the pumps to operate. So, if you're circulating hot water through the building, the end of 5 minutes, it kind of shuts off. Once it's no longer needed. So this goes more into the demand recirculation controls. I don't know if I've seen this so much in a commercial building, but I've seen it in houses where you have a little push button, and the farthest bathroom you go in, you push the button, it starts on demand, kind of spinning the water through the system, and it runs for a certain amount of time, and then it shuts off. So now you have hot water right where you need it. In essence, the same thing, probably a larger volume, and it limits the warm water that returns back into the cold water piping into the system to 104 degrees, because you don't want to end up superheating this water. The hotter you get it, the more you circulate it through, the hotter it gets. And well, there's no need for that, and code won't let you have water that hot. So. I told you we talk about maintenance information system commissioning. So larger systems, AC equal to or greater than 40 tons, 480,000 BTUs, and total heating and water heating equipment equal to or greater than 600,000 BTUs. Those will need to be commissioned, and Section 408 tells you all about the commissioning, what's required, and what that looks like. So surface water heating is your domestic type. Your heating water, the big boiler on the left, that's for heating the space. So if you don't meet those requirements, you don't need to be commissioned. Now, should your plans get designed that say they want commissioning, even though these aren't met, that's an engineer's preference. I would imagine they would still need to be commissioned. Even if it's not required by the code, it's required by the design professional. So, from what I understand, it's cost a little bit of money. So if it wasn't needed, I'm not sure why you would want it. But that's kind of that. Existing buildings. So where it talks about existing buildings, and Land touched on some of this. This code isn't intended to, require you to change things, abandon them, remove them, if you're not doing anything to it. If you're adding an addition, the addition needs to conform to the provisions of the code. The existing unaltered portion doesn't need to be brought up to the current code, to this code. It's in existence, it was to code then, it's still to code, much like everything else we do. with mechanical systems, the surface water heating systems, the new stuff that you're adding will need to be brought up to the current energy code. Whatever's existing can stay the way it was. With alterations, the unaltered build portion, so you're changing part of a space. You're not adding anything, but you take a space, you turn it into something else. The unaltered portion remains the same. The new portion comes up to this code. If you're changing the space conditioning and you had a space that had no conditioning in it, or excuse me, low energy space, that is now going to become a conditioned portion of this space, then now that has to be brought up to the code. Again, with the heating and cooling systems, same thing. Economizers would need to be, addressed on the altered portions. The existing portions, not so much. What happened? Maybe that's the end. Making noise like I don't have any more slides. I thought there was one or two more. I think that's all I've got. So I'll entertain questions and hopefully I can answer them to the best of my ability. Let me figure out how to stop sharing. All right. Does anyone have anything to offer?
Real quick, I just, this is Brad, by the way.
Oh, Brad.
Like you, I'm still a bit confused about the maximum pipe length relative to lavatories. It seems like there's no escaping that your water heater is 1,000 feet away from the lavatory, and I don't know how that can be mitigated. Does that mean, or what is trying to be said?
Okay, so yeah, and that was my initial reaction. So what we're going for is obviously your heating source of heating water is going to be some distance away. What they're talking about is the piping off of your main transmission line, for lack of a better term. So you run an 1.25 inch heating line down a hallway and you branch off. So the branch line can't be any more than 2 feet.
It's almost like we're treating the main line as a manifold in that instance then.
Right. So what you've got to do is you've got to loop it by it somehow. Excuse me, and get the larger pipe. I mean, it's going to be a lot more pipe, I think. Logistically, it's, say you had an 1.25 inch pipe and you're running down the hall and you got a public lav and you got to go to the other end of the building. So now, in essence, you've got to get this 1.25 inch line over, down, and back up and out, like make a continuous loop. So you don't have more than the 2 feet of 1/2 inch pipe, smaller pipe. I mean, you don't see a lot of guys running 3/8 or 1/4 inch. Those are tubings, typically from the outlet of your angle stop to your fixture. That's not what we're talking about. We're talking about from your transmission, your main line, to your angle stop. So on a gang bathroom, you run it right down. You drop your pipes down and run them, and then you just stub them out. It's a little easier there if you've got a single public lavatory. you're running a little larger pipe a little farther distance to make a loop out of it.
That's perfect. Yep, that totally makes sense now. Thank you.
Yeah, so that picture, and this will all be up on the website, and that picture kind of, I showed you the two different ones where they loop down and back. You had three lamps next to each other. I don't know why you would do this, but loop down to one, up into the ceiling, over and back down to the next one, and just run it right through the wall, and go right by them all. But that's a big change, and that's going to be, a design and an installation adjustment, because that's not typically what we've done as plumbers in the past or designers in the past. Like you said, you make a big loop around the building, you start branching off and dropping down to things. But as we all know, when you're waiting for hot water to wash your hands, you get tired of waiting and you wash them with cold and you leave. And then the next guy might get some hot water. But anything else needs to be addressed? Questions, comments? Doesn't appear so. Well, I appreciate everyone being here. Again, the residential portion will be coming up. We'll make an announcement about that. This is the commercial right now. If you do have questions that come up after the fact, you can email me or call. I'm pretty easy to reach. Just call the city and ask for me. Maybe not the city, but planning, and they can find me. And I'll do the best I can to get you a cogent answer in a relatively short amount of time.
David, I have a question for you. In this lecture, whatever you covered, these are the most important stuff that we should look at. Which, however, IECC cover a lot of stuff. So whatever you cover, we should mostly look for those stuff that you cover. Am I right?
Correct. So the IECC is expansive. It's probably 3 times as thick as it used to be, or at least the last iteration. So what we're doing is I'm kind of giving you the highlights, and I've got several of the inspectors, the plan reviewers here with us looking at this. This is what we're going to be calling for now. And as we uncover things, we're going to start introducing them. We're not going to spring them on you and say, ha ha, code of the day, gotcha, because that doesn't work. So as more things get uncovered, they will get discussed, and they will be implemented. Nothing happens overnight. We're trying not to surprise anyone, including ourselves. So pretty much what we covered is what we're looking for at the moment. It will expand, it will grow. There's a lot of code in there. Can't cover it all in a 45-minute presentation, nor could we understand it all. So as time progresses, things will slowly come out, and hopefully we don't surprise you. And again, if you've got questions about how things happen, or maybe you've been dealing with the 2015 in a different jurisdiction you work in, and you have some insight and knowledge you would like to share, I'm all about that. I'll take all the help and advice I can get as well.
Another question. You show a new energy review checklist. That one will post it when we ask for IECC 2018, because we have a very small IECC checklist right now that we ask. This one is the one that you show in your slideshow. It is different.
That came right out of the book. Should be the same one for the 2018 as before. And oh, by the way, this 2018 is in effect currently. It is, I'll get back to answering your question. Hang on, Nasima. It is in effect currently. You have the option of still preparing until, I do believe, March 1st and submitting under the 2009. After that, it will all be 2018. So at this point, you've got the option for both. Come March 1, you will have the option for the 2018, and that's the only option. The Energy Review Code checklist has changed a little, and those are the things they're looking for. I suppose I could try to bring it back up somewhere, so I know what you're talking about. I don't think you'll see that.
Dave, this is Land. The Energy Code checklist is significantly different. It is also not required. Previously, we required that just to affirm the requirements of the Energy Code. That is no longer. That is truly just an aid. We do need that information, especially if you're going down the prescriptive path. Not so much if you're giving us the software, but we definitely need the total heating and cooling BTUs. That is required from the Department of Energy if they want to audit our city.
Thank you. Anything else? Anyone?
Thanks, David. We appreciate you putting this on. As David said, anything comes up, you get starting to designing under this new code and you're not quite sure, don't wait till submittal time. Reach out, give us a call or send us a note, and we'll try to run that question to ground for you and get you an answer, so you're not held up at time of permit. So if nobody has anything else, thanks again, David. More to come in all the sections, but stay tuned and we'll get you some more information. And in the interim, be safe, and we'll see you next time.
Thank you. Take care.
Thank you, Dave.